of my students, and she said, Uncle, I have been finding it difficult to find the potential difference across the resistor with 20 ohms resistance. How do I get that? I said, okay, don't worry, I'm going to teach you the steps you're going to apply. Next time, you'll find something like this. And what I did was, I said, okay, let's look at this. Let's look at solution this way. Okay? The first thing you need to do is to analyze the diagram. Okay? Understand that these two resistors with resistances 5 ohms and 10 ohms respectively are connected in parallel. Only this is connected in series with them. Therefore, the current flowing into this is not the same as the current flowing into this 10 ohm resistor. She said, okay, that's it, yes. So the next thing to do is to sectionalize the diagram. Sectionalize, call this section A, and then call this section B, and then call this section C. Then walk through using these sections. Remember to apply Ohm's law, which is V is equal to I and R, product of I and R. She said, okay, that she did all that. I said, okay, there's something you may have missed in the first place. I said, okay, let's find the current flowing, the potential difference across this. Already we have the current flowing as 2 amps, okay? Current flowing into this resistor with resistance 5 ohms is 2 amps. But the current flowing into this resistor with resistance 10 ohms is not given. Yes. Let's use this and that to find the potential difference across these 2 ends. She said, okay, let's go on, and we start. We call it VA section. Call it section A. Let's resolve section A first. And what we have there is IA is equal to 2 amps, right? And we have also RA, that is this, equal to 5 ohms. So what do we do? With this and that, according to this law, Ohm's law, we can find our VA. VA is equal to IA times RA. That's Ohm's law. We substitute. We put the values of IA and RA, this and that. So we have that as 2 times 5. And this gives us 10 volts. That's it. 10 volts. Therefore, VA, which is the potential difference across section A, is given as 10 volts. Alright? You take note of this. Now, there is this rule that we must understand. She asked, what rule? I said, yes. That when you have 2 resistors connected in parallel, you must understand that the current flowing in the resistors in parallel is not the same, but the potential difference across them is the same. She said, wow, that's it, yes. The potential difference between this and that is the same, but the current flowing in each of them is not the same. She agreed. And from there, it means that VA is equal to VB, right? And our VB becomes IB, right? And then RB. Good. That means section B, we are into section B now. And we continue that way. At the point, she now understood, she has now understood that since the potential difference here is the same, she can use it with the value of the resistance here to find the current flowing. And we go from this point. VB is equal to IB, as we have stated earlier, and RB. And this gives, because we're looking for what? Current. Already we have RB, we have this now. So IB is the subject now. Let me pick chalk. Okay? So what do? We make VB. We make IB the voltage, the subject. It becomes VB all over RB. B because that's the section we are solving. Alright? We are trying to find the current flowing into this very particular resistor with resistance 10 ohms. That's all. Okay, we continued. My student and I, we continued. And I told her, let's put this, because we already know it's what? 10 volts. So it's 10 volts. And then let's put this, because we know the value as 10 ohms. Alright, we now have this. Remember our IB. Very simple. Okay? This divide themselves. We have this 1 amps. Therefore, okay, IB, the current flowing into resistor with resistance 10 ohms, is given as 1 amp. 1 amp, or 1 ampere, so to say. You can see, we have found this. But we have not found the potential difference across this. She asked again, say yes. But since we now know the value of IB, that's the current flowing into this, all right, we can now find the total current. We cannot find the total current because the current flowing into this will emerge at this point. The current flowing into this will also emerge at this point and recombine at this point. So we have 2 amps, that's this, right? We now know that the current flowing into this is 1 amp, and that 1 amp is this. 1, okay? It's going to recombine. It's going to combine with 2 amp here, and we have total current flowing here as well, 3 amps. I hope this is not too small to be seen, okay? 3 amps flowing into this point. So let's find out section C now. We are now into section C. And she was very, very happy because she now understood the steps she would have applied in the first place to be able to find whatever the potential difference across the 20 ohm resistor is all about. So we begin again and then say, I see that's the current flowing into this. Now is IA plus IB total current found. We then have, for IA we have 2 amps, right? For IB, there is no need putting amps again, all right? For IB, we have 1. And then IC total current flowing here. The combined current flowing into this is now 3 amps solved. So we've gotten the current. We found the current flowing there, 3 amps. She said, wow, that's interesting. Of course, because you are now beginning to understand what you should have done in the first place to be able to find the potential difference across this particular resistor with 20 ohms resistance. But it does not end there. I told her, yes. She said, what next? We just found the current. What about the potential difference? PD, that's this. Ohm's law again, and that is VC, because we are talking about section C. And that's our concern. VC is now IC and then RC, so to say. And we substitute wisely. We have, for IC is already 3, right? Good. And then for RC is the value we have here, which is 20. So the final this thing we're going to do is simple multiplication. 3 times 20 is going to give you 60 volts. Alright, VC. This means that the potential difference across the resistor with 20 ohms resistance is 60 volts. My student was surprised. Wow, Uncle, how did you do it? Exactly the way you've been watching me do it on the board. Okay? So that is it. So when you have something like this, try to analyze the question. From analyzing the question, move on to the appropriate steps and formula that will give you what you want. Exactly how I thought my student when she brought on this question. you have any question, please don't fail.